In lesson 4.3, students are introduced to the idea that electrons in an atom exist on what are called energy levels. Here we try to show an atom like cut away. This is the nucleus where the protons and neutrons are, and these are the energy levels where the electrons exist. And here's a cross section. The idea is an atom has a certain number of electrons. You can have 2 on the first level, 8 on the second, 8 on the third, and 2 on the fourth, because we only go up to 20 elements in middleschoolchemistry.com. So that would be the pattern of the 20th element: 2, 8, 8, and 2. In fact, we try to show kids that you can easily identify what the element is just by looking at the electrons in the energy level. Well, it's easy because if you have 2 in the first, and in this case 6 in the second, if you add those up, 2 and 6 is 8, and the number of electrons equals the number of protons. So what element has 8 protons? It's oxygen. So we show kids a sort of periodic table of energy levels, and they get the idea of what the pattern is. Hydrogen is 1 proton and has 1 electron on the first level. Look at helium. It has 2 electrons, and they exist on the first level. But then the first level can only hold 2, so lithium, which has 3 protons and 3 electrons, needs to go to the second energy level. So there's 2 in the first and 1 in the second. You would use this pattern to show kids how it works. If you go to the student activity sheet, students are left with filled in only in the first column here and the last, so they need to fill everything in between. This gives kids an opportunity to think about what they're doing, and that they're only putting 2 in the first and then additional electrons in the second until it has 8, and then they have to go to the third level. We point out to students that the first row has 1 energy level, the second row has 2, the third row has 3 energy levels, and the fourth row has 4. Now, there's a periodic table card game that has to do with energy levels. This is similar to the game that we played in lesson 4.2, just the previous lesson. You'll hand out cards to groups of students, and they'll go around the room and try to put the card at the right element. So this one all has to do with energy levels, though. So a card, for instance, would say the atom you are looking for has this energy level model. Well, this is easy because they just count up the electrons. It equals the number of protons. In this case, there's 5 electrons, so there must be 5 protons. And you just look for the element with 5 as the atomic number, and that's boron. And here's one that's a little different. The atom you're looking for has 2 electrons in the first energy level, 8 on the second, 8 on the third, and 1 on the fourth. But again, you can really just add them up, and that equals 19, so it must be potassium. So kids play this game just to get the idea of what energy levels are like, how many electrons can be in them between elements 1 and 20. We also want kids to see something else, that elements in the same column have similar reactivity. Let's take a look. Here's sodium in water. Now, sodium's pretty reactive. It gets hot in there, it produces a gas, and sodium is right here. So now we're going to look at potassium. It's in the same column. So the idea is that it has somewhat similar reactivity. Now, it's even more reactive, but it's similar in a way in that they both react strongly with water. And now, if you move over 1 from potassium, it's calcium. We think that should be a little different since it's not in the same column. And it is somewhat reactive. It's producing a gas here, but it's not the same. It's not zooming around on the top of the water getting extremely hot. We have another example of this. Here we put sodium in 2 different kinds of acids. Hydrochloric acid at 2 different concentrations and nitric acid at 2 different concentrations. And let's just watch what happens. Again, whoa, the sodium is very reactive in these acids. Now, we think potassium should be somewhat similar because they're in the same column. And it is. It's somewhat similar. And we think that maybe calcium will be a bit different since it's not in the same column. And it's reactive, but not quite in the same way. Not as vigorous. Another thing we want to point out to students is that the reason why sodium and potassium, for instance, are similar in reactivity is that they have the same number of electrons on this outer energy level. If you look, all the elements in this row have just one electron on the outer energy level. And that's the kind of the factor that makes elements act similarly. You don't have to get into that in much detail, but it's a pattern that kids might notice. If you're in an NGSS state, there's a performance expectation, MSPS 1-1, which says develop models to describe the atomic composition of simple molecules and extended structures. That's the idea in all of Chapter 4. We're leading up to it slowly, and we will get there. Although the NGSS standards for middle school don't specifically include content on the parts of the atom or the periodic table or covalent and ionic bonding, which come up later in Chapter 4, your state or district may include some aspects of these concepts to help students develop a deeper understanding of atomic composition of molecules. So the early lessons in Chapter 4, 4.1, 4.2, and 4.3 may be helpful to you in leading up to this performance expectation. If you look at the foundation boxes, science and engineering practices develop a model to predict or describe phenomena, while students develop a model of the electrons on energy levels within an atom, and they see that they affect the reactivity of the atom. Also, this idea that substances are made from different types of atoms, and each pure substance has characteristic physical and chemical properties, all this can come out of the idea that atoms have electrons and that they exist on energy levels which influence how they behave. And the last one, cross-cutting concepts, well, this idea of looking at things in different scales, looking at the substructure of the atom all the way down to the electrons and what energy level they're on, affects how the atom behaves on the macroscopic level. Eventually, we'll see what atoms it can bond to form molecules. So, thanks for watching, and good luck with the lesson.